So I'm just waiting for you to join. Okay, little by little, we can start now. So we want to talk about circles. So I am skipping those pages related to parabolas, okay? That is not included in the Swedish curriculum. You know why Origo book has written that part there. So I'm just jumping to the circles. Okay, so we want to talk about circles today. That's an important geometrical shape for us. So if I have a circle, what do I mean by having a circle? So you know that every circle has a center which lies exactly in the middle. And then it doesn't matter which point on the circle you choose. If you connect this point to the center, the length would be the same if you do it with this point. The length would be the same if you do it with this point. So all of these lengths that you see here are the same, and this is that each one of them is called the radius of the circle. Yes, and then usually we show the radius with r, for example, here. The length of all of these are the same value. Okay, so this is important to understand about the circle, and there are some terminologies going on for circles that I want to review here today, and then we want to rediscover some properties, nice properties of angles which are somehow related to the circle. Yes? Okay, so let me just draw a better picture. Yeah, let me try to use this if possible, make it a little bit better. Yeah, I would say this is reasonably good. So assume that this is your circle. So when we talk about the radius, you know about this. If we talk about the diameter, you also know about this. What is the diameter? The diameter is a line segment whose endpoints lie on the circle, but it also passes through the center. Yes. For example, if this is my center here, more or less here, if this is my center, if I draw this line segment which lies on the circle, this endpoint is on the circle, this endpoint is also on the circle, and it is also passing through the center. Let me call this line segment. This line segment is called a diameter of the circle. Yes? And if I ask you what is the length of this diameter, it's clear. From A to C is one radius, from C to B is another radius. So if the length of the radius is denoted by R, so the length of each diameter is 2 times R. Yes? Very simple. Another terminology that you need to know is the notion of arc. By the way, you need to learn the Swedish words of these, probably it's in the book. So what do we mean by an arc? So assume that you have one piece of your circle. So for example, I start from here up to here. Let me call this point M, point N. Then this part of this circle, this is an arc. Yes, this is denoted by MN. Usually in the books, they put something like this on top of that. And then we call it the arc MN. But of course, when you put 2 points on the circle, simultaneously you are making 2 arcs. Yes, one arc is this little one. If you just consider this one, but of course there is another one. This bigger one from here to here is also an arc. Yes. So, and of course, this might be a little bit problematic because when we just write the arc MN, you might think I am referring to this blue one, or you might think that I am referring to this big one. Some convention is that if I really mean this big one, might be I write it in this way. I write it as MAN, and then I put this arc symbol on top. So it means that I am emphasizing that on my way to N, I am also passing through some point A. Then it becomes clear I do not mean this one. By this symbol, I mean from M to N, but I am also passing through A. Then there is no matter of confusion. When you see this, you exactly mean, you understand what we mean. Okay, but these are minor things. So this is definition of an arc. Something is also important to know is called the arc length. This is, you should be careful about. What do we mean by the arc length? The way that I can define it for you is, for example, take a piece of thread and just bend it so that it exactly overlaps with this blue curve. And then after it is done, just cut it and then stretch it. This has a length, yes? That length is called the arc length. So if I give you a ruler, in principle, it is not possible to measure the arc length, because by arc length, I mean the length here. So this is the distance. If you assume an ant is moving on the circle, the distance the ant is moving is called the arc length. When the ant starts here and ends there, the distance is also not a good word, because sometimes in physics the distance means the shortest distance. So how much this person, if this ant has a car and he's moving with his car on this, the kilometer on the speedometer shows the arc length, how much this ant is moving on this arc. So that is called the arc length. So if I want to measure it with the ruler, this is the only way that I told you. For example, you take something like a thread that you can exactly bend it over on this blue line, and when it is finished, you cut the thread and stretch it, it becomes a straight line. Then you take your ruler and measure from this side, this tip to the other tip, and then that is called the arc length. Okay? But we also have another notion. If I connect this point to that point, this is a straight line. This is different. If I measure by ruler this line, of course, it is clear that the length of this line segment is shorter than the arc length. So do not confuse these two notions together. This line segment is called a chord. Yes? So when you say a chord in a circle, it means that pick up 2 points on the circle and connect them, for example, with your ruler. The line segment that you create in this way is called the chord, a chord. And you can call it just chord MN. Yes? Of course, it is clear what is the longest chord in every circle. Every diameter is the longest possible chord in any circle, yes? And what is the longest, what is the biggest or largest arc? The circle itself, yes? If you consider the whole circle, that would be the largest arc possible on any circle. And what is the maximum for arc length? The maximum of arc length is the perimeter of the circle. And hopefully you remember, I don't know, this is not mentioned in the book, but this is so famous, let us memorize it here. So if I ask you, what is the value of the area? What is area? So let me denote area by A. So if you remember, it is pi. And of course, why this formula correct is not that trivial. Okay, but let us, for example, at least know it, and then might be we can talk a little bit about it in math 4 or 5, why these formulas are correct. So A is pi r squared. So if you want to find the area, so let me write the area. Don't get confused this A with that A. So let me write the area is equal to the famous pi number multiplied by the square of your radius. That is the area. And the perimeter or the circumference is 2 times pi times r. But in some books, you see they write pi times d. Because they multiply r by 2, you multiply r by 2, it becomes the diameter. So they denote the diameter by d. So some books write pi times the diameter, some books write 2 pi times the radius. So this is the longest actually arc that you can have in a circle. So these are general informations that you need to know about circles. Radius, diameter, arc, chord, and arc length. Yes? There are two famous angles that this would be the topic of today's lesson. You need to know about circles. So let me clean these extra things. Now I want to introduce you this new lesson, actually, more or less. Okay. So an angle whose vertex is the center of the circle and other sides are radii of this circle. This angle that you construct here, let me call it theta, this angle is called a central angle. So what is the definition of the central angle? A central angle is an angle whose vertex is at the center of the circle, and two legs of that angle are the radii, one radius, the other radius of that circle. And now if you have this situation, there is also a name for this arc. I would say that MN, the arc MN, is the arc, this is the terminology, subtended with the arc that subtends angle theta. Or I have forgotten a little bit which way is it. Is the correct English word for that? So MN. Okay, so let me put a question mark on it. Might be this English sentence is not that correct, but the word I'm sure about this word, but how should I use it in the sentence? Might be if Cameron is there, can help me through Zoom about it. Okay, there is another angle which is called inscribed angle. Inscribed angle. Okay, what is the meaning of an inscribed angle? If I have my vertex on the circle and the legs of that angle are just chords, okay, so for example, let me just draw this one. This angle that I construct here, let me call it alpha, this is an inscribed angle. So an inscribed angle is an angle whose vertex is on the circle. For the central angle, the vertex was the center. But here, this can be any point on the circle. And you just have two chords. One is one leg, the other one is the other leg. The angle that you construct in that way, this is called an inscribed angle. For example, if I want to draw another one, you can take this one, I don't know, you can connect this here, and then you can connect it, for example, there. And then this angle, let me call it beta. This is also an inscribed angle. So this is the arc subtended by this angle. And now this from here to here, if I change my color, from here to here, yes, this black part is the angle subtended by alpha. And this arc is the angle subtended by theta. So these are the things, the angles that we are interested to discuss the properties of these angles. Any questions? Any questions, people at home?
No.
Okay. But now today we want to discover something, the relation between a central angle and an inscribed angle, both of them subtending the same arc. Okay, so what does it mean? It means that, let me draw another picture here for you. So this is the lesson today. Assume that I have a circle. And now I have a central angle. So let us, for example, consider this central angle. Let me just do it correctly by doing it here. So assume that this is your central angle. Of course, unfortunately, I have to be in a school. Otherwise, teaching it using GeoGebra was more effective. So assume that this is your angle theta. Okay, and then you have another angle. This is a central angle. So let me call this one center C, and let me call this M and N. If I ask you which arc is subtended by this angle, you would say this MN is the arc subtended by this angle. Now, let me draw any inscribed angle. Inscribed angle, it means that I should choose the vertex somewhere here on the circle, and I want to subtend the same arc with that angle. Okay. For example, let us, for example, consider this simplest possible case for the time being. I draw this from here to here. Yeah, let me just draw it some way that you can understand it. So this is one leg, and the other one, let me just do it here. Yes. So let me call this new angle alpha. I am not drawing them randomly. They are arbitrary up to this point that you need to respect. If I ask you what is the arc subtended by central angle theta, you will point the arc MN. If you ask you the same question, what is the arc subtended by inscribed angle alpha, again, you will point to the same arc. So this is crucial. I am not comparing any central angle with all the inscribed angles. No, I am comparing the size of a central angle with any inscribed angle that subtends the same arc as the central angle does. This is crucial. And there is, if you respect these rules that I just mentioned, there is a very nice relation between this theta and this alpha. And we want to discover that. Okay. So we want to discover what is the relation between the size of angle alpha and the size of angle theta. I don't know, might be it is not that clear from the picture that I have drawn it here, but you can use GeoGebra to convince yourself. But of course, that GeoGebra is not a mathematical proof. You need to have an argument for that. Okay, so let me try to see that. My claim is that the size of this central angle is 2 times larger than this inscribed angle. So this is the claim. We want to show that theta is 2 times larger than alpha. So this is what we want to show. But how can we show that? First of all, I remind you something from Math 1C. If you remember, we talked about a triangle in Math 1C, and hopefully at that point I could convince you by mathematical argument that the sum of these 3 angles is equal to 180 for any triangle. Yes? So A plus B plus C angle is 180 degrees. Here, because there are no matter of confusions, I can also get rid of those little hats on top of those signs, but you can keep it like this. We already know. And then, if you remember, we talked about an exterior angle. These are called interior angles of a triangle, but for each angle, you can also consider an exterior angle. For example, if I ask you what is the exterior angle for C, you will show this one to me. Okay? And then if I ask you what is the, so let me call this one X. So you know that angle X plus angle C is 180, because if I go from here up to here, it is just a straight line, and that would be 180 degrees. And now this is 180, that is also 180. So this means that this is equal to this. So this means that A plus B plus C is equal to X plus C. And then I move this C to the other side, it becomes negative C, and this will cancel this positive C. And what is left for you is the angle X is equal to angle A plus angle B. So that is one result that we had it in Math 1C. I don't know if you have forgotten or not, but I'm just refreshing your memory. So how we can read it in English or Swedish? We can say that an exterior angle is equal to the sum of 2 interior angles which are not adjacent to this exterior angle. Let me just elaborate a little bit more. So here, this is an exterior angle. If I ask you what is the angle adjacent to X, you would say C. Ignore C, there are 2 more. If you add these 2, it becomes X. So this is what you need to understand. For example, if I draw another picture for you here. So let me call this one A, let me call this one B, let me call this one C. If I ask you, what can I write for this angle X? Hopefully you agree with me, this angle is the exterior angle for angle A. Yes, this one is the interior angle corresponding to X. If I ask you, what can I write for this exterior angle? You would say that I ignore the one adjacent to it. There are 2 more left for me. I add them together. This becomes X. So this should be easy for you to realize. By looking at the picture, you should be able to immediately write that in relation. So is that clear? Everyone clear? Okay, but how do you think that this will help us to show that this is indeed the case? Okay, do you have any idea what to do? If you don't mind, because this would be, let me put C a little bit here. It doesn't interfere with what I'm going to do next. So I want to show that theta is 2 times larger than alpha. The trick is this. The trick is to take this point and this point and put your ruler next to those and connect them and continue the line segment. So you see, I hope that this is visible through YouTube as well. This red one. So what I did, I took this. Okay, thank you. So this point and this point, I connected together and I continued. Then I get a point of intersection. So let me call it P. Okay, now I need to do some adjustments. This was alpha. It becomes into two. It is actually divided into two parts, but not necessarily equal parts. We don't know. But we know that this is divided into two parts. Let me call one part alpha 1. Let me call the other part alpha 2. If you ask me how much is alpha 1, alpha 2, I don't know, but I know something. I know that if I add alpha 1 plus alpha 2, it becomes my original alpha. Is alpha 1 equal to alpha 2? We don't know. It might be the case or might not be the case. The same scenario, this theta will be divided into two parts, not necessarily equal parts. So let me call one of them theta 1 and the other one theta 2. Again, what I know, I don't know something about theta 1 and theta 2, but I know that if I add them, it becomes my original theta. I hope that this picture is clear. It's a little bit narrow, so you need to understand what is going on. I don't know how to show it. So let me slightly try to color this triangle. It's a narrow triangle here. Yes, this narrow triangle. I want you to more or less in your head rotate this picture so it becomes something like this, yes? This will go up here. So this C will go up, this B will go down, this would be A. Yes, it's comparable. This triangle, when I rotate it, it's comparable to this very narrow triangle. I want you to be able to visualize it clearly. Okay, so I hope that every one of you now agrees by this rotated picture. This X will be here. This will be an exterior angle. So if you compare this picture with this narrow triangle, hopefully you see that this theta 1 here is playing the role of this X. Yes, is that understandable for everyone? Yeah, okay, good. So then what can I write? You can write theta 1, you can write theta 1 is equal to this angle, which is alpha 1, plus this narrow angle. Okay, so let me give it a name y. So this becomes plus y. Yes? And now I can do the same thing for the other side triangle. What is theta 2? If I ask you what can you write for theta 2, you would say that theta 2 is alpha 2 plus this narrow angle. So let me call it z. So it becomes alpha 2 plus z. But now my question for you is this. What is the relation between z and alpha 2? What is the relation between y and alpha 1? And if you know the answer, why? Let us concentrate on this one. What is the relation between alpha 1 and y?
They're angles in the same triangle. Should be.
Okay, more than that. I want something more specific than that. Yes, of course they are in the same triangle, but they have a very nice relation.
It's the same angle because both of the sides connecting to the middle is the radius.
Exactly. Is that Benjamin? Was it Benjamin?
Yes.
Okay, thank you. Yes, you are completely right. He is saying that these two angles are exactly the same. Yes, it is clear. Why? because it might not be very clear in my rough picture, but if I ask you what is this blue line, it is connecting the center to the rim of the circle. So it is the radius. So CM from C to M is equal to the radius. Let me ask you the same question here. Let me give this name A. What is C to A? From C to A is also from the center to the rim of the circle, which is R again. So this means that actually there is no difference between the length of CM and the length of CA. So this means this very narrow triangle is an isosceles triangle. And when it is isosceles, it means that these two angles are exactly the same. Yes? So this means that alpha 1 is equal to y. For the same reason, if you follow the same logic, but on the right side triangle, you will realize that CM is the radius, CA is the radius, so they are equal. So even this triangle is an isosceles triangle, so it means that Z is equal to alpha 2. So I don't write it down again, but you continue. And then for the same reason, you understand that alpha 2 is equal to y. So now what can I do here? I can go back and write it a little bit better. Alpha 1 and y are the same thing. So I can write alpha 1. Instead of y, I can write alpha 1 again because they are the same. But alpha 1 plus alpha 1 is nothing except 2 times alpha 1. Yes? And I have the same scenario here. Z, oh, sorry, I made a mistake here. This is Z. So alpha 2 and Z are the same. So instead of Z, I can put alpha 2, but alpha 2 plus alpha 2 is 2 times alpha 2. But I hope that this is clear. Can you tell me now how can I finalize the problem?
Well, you say that, okay, so theta 1 and theta 2 together, they're just theta.
Yes.
And you say theta 1 is to alpha 1.
Yes.
And theta 2 is to alpha 2.
Yes.
So then you can say, well, okay, the theta 1 and theta 2 are equal.
No. Theta 1 and theta 2 might be equal, might not be equal. We don't know.
Okay.
But we know the sum is theta.
Well, in that case, I've lost my...
No, you need to add them. Just simple as that. You add them side by side.
Well,
so it becomes theta 1 plus theta 2 is equal to 2 times alpha 1 plus 2 times alpha 2. But if I ask you, what can I write instead of theta 1 plus theta 2, it's still on the board. It's theta. And what can I do on the right-hand side? I can factor a 2 out. I'm using algebra here, connection between algebra and geometry. So I am factoring 2 out.
Right. Okay,
but what is alpha 1 plus alpha 2? Yes. So it is alpha. So it is 2 times alpha. So that is an extremely simple, but a very nice relation. But let me emphasize again. This arc should be the same arc, both for the central angle and for the inscribed angle. Okay. Now let me, for example, ask some questions from you. Okay. By the way, you might say that this is not the only scenario. Might be this point is here. By the way, all of them are correct. You can convince yourself with the same arguments, but this is one of the arguments for one particular type of shapes. Okay. So let me try to motivate you about other scenarios. So I want to erase that. Is that okay? Yes, can I erase it? Okay, so let me just erase this. And then let me draw. So I just want to draw it with my hand, not to spend so much time. So for example, I draw this angle here. Give it a name alpha. Okay? And I draw another inscribed angle here, for example. I connect it to this point. I connect it to this point. And I call this beta. Okay? None of them are central angles. Both of them are inscribed angles. But they are subtending the same arc. That arc is, let me just draw it with red. That arc is this arc. So what is the relation between alpha and beta? What do you think?
They're equal.
Okay, they are equal, but why? Because this is not the same theorem. Do you see that? There is no central angle involved here. The answer is correct. They are equal. So that's extremely powerful. Yes? Why?
The formula for the central angle.
So what? How should you? Okay, tell me a step by step. There are no central angles here. Do you want me to draw one? Okay. So let me just describe. If you have two inscribed angles subtending the same arc, they have to be equal. Why is that the case? I would say that let us find the center of the circle and let me connect this center to this point, and let me connect this center to this point as well. And let me call this central angle theta. Now, what is the relation between theta and alpha? We just learned. If I have a central angle, if I have an inscribed angle, both of them subtending the same arc, the size of the central angle is 2 times larger than the size of the inscribed angle. But that is, this blue one is also an inscribed angle opposite to the same arc. So again, the same theorem makes me to write this. Theta is equal to 2 times beta. On the one hand, theta is equal to 2 alpha. Theta is, on the other hand, theta is equal to 2 beta. What does it mean? It means 2 alpha is equal to 2 beta. And now I divide both sides by 2, I get alpha is equal to beta, and that is what we were claiming. So it's a very nice property, you know, it doesn't matter where do you choose this point.
But I think there's another way to...
Yes, please. Yeah, just tell me how.
Yeah, okay, so there are the two lines are crossing each other, and then we know that the opposite angles will be equal.
Yes, those are called vertical angles.
And then they're both, yeah, exactly.
This angle,
so they're both right angle triangles, right? So that means they share the same angles.
No, they are not right angle triangles. How do you know that they are right angle triangles?
Well, aren't they? They look right angle. I guess
no. Be careful. In geometry, usually the figures are not to scale. If I want to say that this is a right angle triangle, I have to show it here for you. If I don't do it, it means that you cannot use it. Yes, this argument, this might be the case that they look like a right angle triangle, but even if they are not right angle triangle, still this conclusion is correct. So I would consider this is a good solution. Okay, so be careful. You are not allowed to presuppose something just based on your intuition. By the way, even if this looks like 90 degrees, how do you know? It might be 89 degrees. If it is 89 degrees, your eyes cannot differentiate between 89 degrees and 90 degrees. So, yeah, in geometry, you are not allowed to rely on your intuition about the picture. Be careful about that. Yes, is that okay? Okay, so now let me, for example, draw another one for you. If I just do it from here to here, I don't know, this angle gamma, I don't know, I take this point. Let me call it, I don't know, beta. Beta I use alpha, beta, gamma, and theta. Let me use, I don't know, lambda. Yes, all these angles that you see, it's very nice. Even if you don't know the size, but you know that all of them have the same size because all of them are subtending the same arc. Okay, let me ask you another question. So assume that this is your circle and I draw a diameter. For example, this is the center. I draw this diameter here. This is a diameter. This is my center. This is my point M. This is my point N. Then I choose a point here, any point that you like on this semicircle on top, any point that you like, and then I connect this point to this end point, and I connect this to this end point. What can you say about this angle? What can you say?
I don't know.
Good answer. The answer is it is definitely 90 degrees. This is a very, very important simple property. If you have a circle, if you draw any diameter that you like and take a point on the circle, any point you like, it doesn't matter. If you connect that point to the ends of your diameter, you make an inscribed angle. That inscribed angle is always and always 90 degrees exactly. But why is that? It's very simple. If you don't mind, let me take this C and put it on top here. And I am asking you one question. Do you see any central angle on this line? The center, the vertex is on the center. One leg is CM, is the radius. Another leg is CN, is also the radius. So definitely this is a central angle. But you know the size of this central angle, yes? What is the size of this central angle? It's 180. If I ask you, what is the arc subtended by this central angle? You would say this arc is the arc subtended by this central angle. What is the arc subtended by this angle? Again, the same arc. Do you see? The same arc is opposite to this central angle. It is also opposite to this inscribed angle. But then we learn that the size of the central angle is 2 times larger than the size of the inscribed angle. Yes? So the inscribed angle, the question mark, should be 90 degrees. So that's extremely important to know. It doesn't matter if I choose this point and I connect it here and here, this angle would be again 90 for the same reason. If I choose this point, if I connect it here and here, this angle would be again 90. Yes? So this is a very important property here. Yes? Understandable? Okay, now let me ask you another question. So that
kind of.
So why kind of?
I'm still a bit confused why, and what about your explanation why question mark is 90 degrees?
So because do you agree that this is a central angle or not?
Yeah.
So let me just redo it again. So here, so let me do it like this. I find the center, I draw this line, and I draw the opposite line. Yes? So this becomes a diameter. So this is a central angle.
Yeah.
This angle is a central angle. And what is the size? It's clearly 180, yes? If I ask you what is the arc subtended by this central angle, you would say that I will find this point. I will find this point. This is the arc subtended by that angle. This is on the one hand. On the other hand, let me pick a random point here, any random point, and then connect this one here and here. Now I am asking what type of angle is this? You would say this is an inscribed. This is an inscribed angle because the vertex is on the circle and I have two chords as the legs of my angle. So this is definitely an inscribed angle. But now I repeat the same question. What is the arc subtended by this angle? You would say, I choose this point, I choose this point. Again, you will show me the same arc. Hopefully you agree. So it means that this is a central angle, this is an inscribed angle. Both of them are subtending the same arc. So it means that the central angle should be 2 times the inscribed angle. And then this means that the inscribed angle is 90
Why is
degrees.
it 2 times?
Come on, we just showed that, yes? We just showed that the central angle is 2 times the inscribed angle, didn't we?
Okay.
That was the whole lesson, yes? The inscribed angle is always...
I was just confused that you put that in there.
Okay, but yeah, that's the same story. We just find a theorem we discovered. So we proved a theorem together. Now we are using and exploring its consequences. Yes?
Okay, yeah.
Okay. Another thing, yes?
Cameron wrote something on the chat. Did you read it?
No. Can you read it for me, please?
Okay, yes. He's saying, I think that your terminology is reversed. I believe that the angle theta subtends the arc.
Yes, that was...
the arc subtends the angle theta.
Okay, thank you very much. So this is that. Thank you very much, Cameron. So angle subtends arc, yes? Yeah, that was my doubt about it. So I shouldn't say... So I think I am using it correct. I am saying the arc subtended by the angle. So if you want to write angle subtends the arc, is this... So may you confirm that this is what Cameron wrote, yes?
Yes, he's saying, I believe that the angle...
Yes, I also believe that this is the correct... So angle subtends arc. But now I am automatically telling it in the right way. I am saying arc subtended by angle. So I think, no, I know I was confused when I started, but suddenly automatically I told the truth. So I think this is also, I hope that Cameron also can confirm this. This is the way that I am using. If I bring arc first, I write it in a passive voice. Arc subtended by angle, or angle subtends arc. Yes. So definitely this is 100% correct, but let us see if Cameron can also confirm that. Anyway, thank you for cooperation. So another thing that I want to talk, and would be that the last thing we want to talk, because Sarah is here to have an exam and I want to give her time to have enough time. So if I have a quadrilateral, just a random quadrilateral, a shape with 4 sides, if I give you this angle alpha, beta, and gamma, and theta, what do you know about alpha plus beta plus gamma plus theta? We had it in Math 1C. What is that?
160.
No.
360.
360. Thank you. Yes, who was it? Yes. So Abdul Manan, I think you was your voice. Okay.
Abdul Manan.
Yes. Okay. But now let me ask you something. Is there any guarantee that alpha plus theta is 180, beta and gamma is 180? Of course, this might be the case, but there is no guarantee for that. Yes. What we know that the sum of these 4 angles is equal to 360 degrees. It doesn't mean that the sum of these two are 180, the sum of these two 180. It might be true or might not be true. We don't know. Okay? But I want to draw the same kind of quadrilateral, but inscribed in a circle. So what I do, first I draw a circle. Yes. And then I draw a quadrilateral inscribed in the circle. Inscribed means the vertices should lie on the circle. So for example, take this point and then draw it here. And for example, here, and then here, and then, yeah, we can make it more different. Yeah, so for example, here and then here. So I am trying not to draw any particular shape. This is just a random quadrilateral. And let me just give this a name: alpha, beta, gamma, and theta. The interesting thing happens is this. If this is the situation, still, if I ask you what is alpha plus beta plus gamma plus theta, you don't need to wait at all. The answer is again 360 degrees, that's for sure, yes? Because that's a quadrilateral. It doesn't matter if it is inside the circle or outside the circle, who cares? But if this is inscribed in a circle, we can say more. We can say that these ones that are opposite together, alpha plus beta, alpha plus gamma is 180, which we were not able to conclude there. We can also say that beta plus theta is again 180. So you see, this is completely okay, because if I ask you what is the sum of all of them, you will still say 360 degrees, which is correct. But when it is inscribed in a circle, you can make sure that the angles opposite together add to 180 individually. Okay? So this is very important. Can you say why? For example, let us concentrate on number 1. If you understand number 1, of course, immediately you understand number 2, because the sum of all of them is supposed to be 360 degrees. If the sum of these two is 180, the contribution coming from the other one is also 180. So let us, everyone, concentrate and try to convince ourselves, based on what we learned today, that alpha plus gamma is 180. This is very important to understand how to think in these kinds of problems. So what type of angle is alpha? I hope that you immediately realize that alpha is an inscribed angle. Why? Because the vertex is on the circle. This is a chord. This is also another chord. Yes? So alpha is an inscribed angle. For the same reason, gamma is also an inscribed angle. I want to show that the sum of two inscribed angles is 180. in this picture. How can I do that?
Maybe you could start off by drawing a line from beta to theta.
Beta to theta, and then what?
I don't know. Maybe it will make it easier to see.
No, but it doesn't work. No, because today's lesson is about inscribed and central angles. So if you want to solve this problem, apparently, because these are inscribed angles, you need to connect it with some kind to a central angle.
Well, you could draw a central angle from that line, right?
No, because there is no guarantee. Because if I connect these two, might be the center is here. Actually, in my picture, it seems that the center is here. So there is no guarantee that this line passes through the center. But might be, this is a good idea to connect, instead of connecting these two things directly together, let me connect this one to the center and connect this one to the center. Okay? So this is the idea. The idea is to say that, okay, somewhere is the center. Let us call it C. Connect this center to this point. Connect this center to that point. Okay? Now, I am asking you this question. Do you see that this is a central angle here? Let me call it, I don't know, X. A central angle, call it X. This central angle subtends this arc. Yes? This is, you need to train your eyes. So here, let me just go it. So this arc is subtended by this central angle, or this central angle subtends this arc. I am asking you the same question for this inscribed angle. You see, this is one point, the other point is here. What is the arc subtended by this angle? Again, this dotted arc. So then it means that I have one central angle, one inscribed angle, both of them subtend the same arc. So do you agree with me if I write X is 2 alpha? Yes or no? Yes, is that understandable for everyone?
Yes, yes.
Okay, this is one thing. Now switch your perspective, switch your point of view. So let me, because I don't want to confuse you, remember this is X, but I momentarily erase it. Yes, what's the idea?
If we make another central angle on the opposite side.
Exactly, exactly. So that's correct. So let me just see this. Let me. Yes, this
X
one.
Example-wise, y becomes 360.
No, before doing that, yes, completely right. Thank you.
And
So now, yes, that's correct. That's correct. So I would consider this angle. Do you agree that this angle is also a central angle? Yes, because the vertex is the center. One of them is the radius. The other one is also radius. So by definition, this is a central angle. What is the arc subtended by this central angle? This arc. This arc is subtended by this central angle. What about gamma, which is an inscribed angle? Is it an inscribed angle? Yes, the vertex here, the chords are here. What is the arc subtended by gamma? Is again the same red dotted arc. So gamma is inscribed, y is central, both of them are subtending the same arc. So the size of the central one, y, is 2 times larger than gamma. Yes? Now let us put x back. Do you remember this was x? Okay, now let me add them side by side. then x plus y becomes equal to, between these two, I can factor a 2 out, alpha plus gamma is left. But it is completely clear what is the sum of x and y. Is it clear? It is 360 degrees. So x plus y is 360 degrees. On the right hand side, I have 2 times alpha plus gamma. But my goal is to find this. This is my question mark. So I divide everything by 2. So 180 becomes alpha plus gamma. And that is exactly what we wanted to show. So you see, this is something very new probably for you. But little by little, there are very nice exercises in the book. The next session, I will give you more examples. But then we have to go to the next lesson. So this is a very nice property of the angles in a circle. Okay? So if you don't mind, I want to end the meeting now. So I will be 1 minute in the Zoom and then I end the meeting. I want to make a little bit of rest and then start another exam with Sarah. Okay, thank you very much for being here with me.